Well, hello, my little triglets. How are you? All right, today's lesson is kind of a long one, not overly complicated, but just kind of takes a while to show you all the different possibilities. So, section 6.5, and we're going to talk about trig equations. Okay, this is very algebraic. If you had an algebra equation like this, if I asked you, does x equal 2, you would hopefully say no. And if I asked you, does x equal 1, you would hopefully say no again. And if I asked if x equals 3, you'd say yes. About time you got that right. So all of these problems that we're going to do today don't have, they're not identities. They don't work for every single x value. So they work for some, just like this one only worked for this, but not the other ones. Okay, so the first one I'm going to talk about is the sine of x equals 1/2. So it's asking what angle is that true? Okay, so you got to think about your circle. The sine of x equals 1/2 when I'm going up on the y-axis halfway. So then you go across in both directions, and we have one here at pi over 6, and we have one here at 5 pi over 6. So x can be pi over 6 and 5 pi over 6 for it to work. Okay. Now, technically, this is happening between x be between 0 and 2 pi. Technically, it could be infinite solutions because I could always add 2 pi to this many times and get lots of other answers that will still work. All right, to represent that, the book writes it as plus 2 pi n. Okay, so if you ever see that, that just means they're including all answers, not just the ones from 0 to 2 pi. Okay, let's try some examples here. So the first type you're going to run into is when you have a single trig function. So just sine or just cosine, for example. So I have 3 sine x minus 2 equals 5 sine x minus 1. Now before I solve that, I want to show you the algebraic way to do it. So instead of sine x, I'm going to have a. So 3a minus 2 equals 5a minus 1. Now every one of you knows how to solve this. First thing I'm going to do, I'm going to get the a's all on one side. So I get negative 2 equals 2a minus 1, and then I'm going to add 1. So I get 2a equals negative 1. Divide by 2, so a equals negative 1/2. Okay, so we're going to do the same process on the left. So I'm going to subtract 3 sine x from both sides. That will leave me with negative 2 equals 2 sine x minus 1. Next step, just like we did here, we're going to add 1 to both sides. So negative 1 equals 2 sine x. Then divide by 2, so negative 1/2 equals sine x. But I'm not interested in sine x. I want to solve it for x. So this one we're finished. This one we have to keep going. Keep going. So we need to look on our circle and ask ourselves, where's sine x negative 1/2? So that would be here and here. So those answers are 7 pi over 6 and 11 pi over 6. Okay, so those are the two answers between 0 and 2 pi. All right, the second process is when you might have multiple angles. Now what that means is instead of tangent of x equals 1, I'm going to talk about tangent of 3x equals 1. Okay, but this is the problem, but I'm going to use this to actually solve it, and then I'm going to change my answers at the end to represent it being tripled. We're actually going to divide our answers by 3 to compensate for being tripled in the beginning. So there are 3 little mini steps that you have to do to solve these multiple angle ones. The first one is to ignore the 3, or if it was a 2, you'd ignore the 2. The second step is you need to go 3 trips around. Again, if that was a 2, you'd go 2 trips around. the circle. And then the third step is to multiply the denominator by 3. And that's the same as dividing by 3. So let's think about this. Where does tangent of x equal 1? Well, hopefully by now you know that tangent is sine over cosine, so the combination has to be 1. That happens at pi over 4 because those are both root 2 over 2's. So pi over 4, and then the two negatives would also be, that would be 5 pi over 4. So those are your two answers. But I need to go 3 trips around because there are more answers when you triple the x. There's triple the amount of answers. So to go around, all I have to do is add 2 pi. So I take my two answers, 5 pi over 4, and I'm going to add 2 pi to that. Well, 2 is 8/4, so my next one would be 9/4. And then if I add 2 pi again it's 8, so that'd be 7 pi over 4. Okay, so let's look at 5 pi over 4. If I want to add 2 pi to that, remember 2 pi is 8/4, so 5 and 8 is 13. And add 2 pi again, and 8 plus 13 is 21. Okay, so those are my 6 answers. There are 6 answers here and here. So I've done this, I've ignored the 3, and I found my answers 3 times around, and I did that by adding 2 pi. Now multiply the denominator by 3. Now the reason we're doing that is because if I take, let's say I use pi over 4 here. What's 3 times pi over 4? That's 3 pi over 4. That answer is -1 for tangent. I want it to be +1. So I need it to get back to being pi over 4. So if I triple, I need to untriple it. Now that doesn't really, it's not a very mathematical term, but if I multiply the denominators all by 3, that's going to untriple it so that when I put it back in here and triple it, it brings it back to normal. So my final answers are pi over 12, 9 pi over 12, which reduces, let's write 9 pi over 12 so you see where it comes from, and reduce those both by 3, and I get 3 pi over 4. Then 17 pi over 12. So those 3. And then over here, I've got 5 pi over 12. And then I have 13 pi over 12. And then I have 21 pi over 12. Reduce those both by 3's, and I get 7 pi over 4. And see how this last one is still between 0 and 2 pi. It still has not gone beyond that. Okay, so those 6 answers in the blue circles are your final answers. And you can test it. You can put this 3 pi over 4 in for x, times it by 3, hit your tangent button in radians, and see if it comes out to be 1. All right, so that's number 2. The third scenario is quadratic form. Okay, so quadratic form. So if I have a quadratic, 2 sine squared minus 3 sine plus 1 equals 0. Now, again, I'm going to do the algebra version over here so you can see the process. Turning sine into a, I have 2a squared minus 3a plus 1. Same problem, I just switched the a in for the sine. Remember unfoiling, factoring, so 2a squared would be 2a and a. 1 is 1 and 1. Check the outside and the inside. Those have to equal -3, so both of them are going to be negative. So 2a minus 1, set that equal to 0. You get 2a equals 1, so a equals 1/2. Then we do the other parentheses, a minus 1 is 0, so a equals 1. So at this step in algebra, you're finished. In trig, you're not quite finished. You have to look on the circle. So let's go back here. Now we already figured out the factoring right here. So this would be 2 sine and sine. The 1 would be 1 and 1, and then we had a minus and a minus. Setting these each equal to 0, I get sine x equals a half, and then sine x minus 1 equals 0, so sine x equals 1. On your circle, sine is a half here and here, so pi over 6 and 5 pi over 6. Sine is 1 up here, remember 0, 1? So that would be pi over 2. So those are our three answers that make this equation up here true. All right, I'm going to do one more, and then the other one, plus another example I'm going to do in class tomorrow. Okay, so let's do one more. All right, the fourth one is just plain old factoring. Okay, we just factored a quadratic, but now we're just going to factor a regular problem. So I have tangent of x sine squared of x equaling 3 tangent of x. Okay, the first thing I want to tell you is about the big no-no. You may not divide by trig functions. Okay, if you do that, you lose some of your answers. Okay, like this problem, it looks like we should be able to divide both sides by tangent of x. But if you do that, you lose that value for the tangent. So instead, we're going to get them on the same side. So I'm going to subtract. So I have tangent x sine squared x minus 3 tangent x equals 0. So for factoring, you want to get one side equal to 0. Now notice they have tangent x in common, so I'm going to bring that out front. You divide it out front, and what I have left is sine squared, and then this minus 3 is left for the second part. Double check. If you distribute that back in, do you get the original equation? If you do, then you did it right. Okay, next, just like in factoring with two parentheses, we set it equal to 0, each part. So tangent of x equals 0. Think about your circle. Okay, if I'm right here, I've got 1, 0. Tangent is sine over cosine, that'd be 0 over 1, so definitely at 0. And then over here is negative 1, 0. You'd have 0 over negative 1, which is still 0. So 0 and pi are the two answers for that. This one I need to add 3. So sine squared equals 3. Square root, so sine of x equals the square root of 3 plus or minus. And square root of 3 is a number that's bigger than 1. Okay, square root of 3 is like 1.6. Remember your picture of the graph, we'll say approximately plus or minus 1.6. When you do the graph of the sine wave, it never goes above 1, so it's not going to be at 1.6. So there is no solution for that part. So these are the only two answers for that question. Okay, and if you try to do it on your calculator, like there are going to be some times where you have to do the inverse sine of 1.6, and you should get error. If you see that, that probably is why that's happening. Okie dokie. Well, we'll finish the rest of the notes in class. Keep the faith. Trig loves you, so love Trig back. Ta-ta for now.